Hi students, so welcome to the next session 2. In previous session we discussed some basics related to inverse trigonometry functions and the graph of inverse trigonometry functions, and we discussed some questions related to principal value, how to find the principal value, and I will continue in the exercise next questions. Find the values of following. The previous session we finished 10 questions. Now 11th one, you need to find these values. Tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. Here the sum of three trigonometric inverse trigonometric functions are there. The sum of these three values we need to find. Directly we don't know how to find these values. That's why consider each one is a one term. For example, let first value I will take x or some anything take y something. Now y equal to tan inverse of 1. Take tan inverse this side, it will become tan y equal to 1. Now tan y equal to, in the place of 1 we can write tan pi by 4. Now y is a pi by 4. Now what is the y means? Tan inverse of 1. Well, how much we got? Pi by 4. Coming to second one, and then that is a z. Is cos inverse of minus 1 by 2. Take cos inverse left side, it becomes cos z equal to minus 1 by 2. Here we need to find this complete value we need to change in terms of cos angles. Directly we can't find in terms of cos, but we know 1 by 2. Cos 1 by 2 which angle? Cos pi by 3. Now 2, we cannot compare this one directly because minus sign is there. That's why we need to convert this one into cos of pi minus theta equal to minus cos theta formula we need to use. So cos of pi minus pi by 3. Now from this what you can write? Z equal to, compare, take LCM 3 pi minus pi, 2 pi by 3. Now it is clearly as for the only there. Now what is the Z means? Cos inverse of minus 1 by 2 value is 2 pi by 3. Next, third value. Third value I will take for example t. T equal to sin inverse of minus 1 by 2. Now take sin inverse left side. Sin t equal to minus 1 by 2. Now sin is 1 by 2 at pi by 6, 30 degrees. It is minus 1 by 2 at minus 30 degrees. We know already. That's why sin t equal to this minus 1 by 2 I am writing sin of minus pi by 6. Now if we compare the angles, t equal to minus pi by 6. What the t means? Sin inverse of minus 1 by 2 equal to minus pi by 6. When you are finding individually only, we need to check it is in the range or not. But while adding the sum of all these values, don't again it is compulsory it is in the range only. It is not required. So individually you have to check with range. Every angle it is in the range of that function only. Tan inverse of 1 or cos inverse of minus 1 by 2, sin inverse of minus 1 by 2. Now coming to that value, complete tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. Tan inverse of 1 how much we got? Pi by 4 plus cos inverse of minus 1 by 2 we got 2 pi by 3. Sin inverse of minus 1 by 2 we got minus pi by 6. Now here for 4, 3, 6, what is the LCM? Okay. Now here for 4, 3, 6, what is the LCM term we take? 12. But 12 is the LCM for this. Take 12 LCM. 12 means how many times multiple? 3 times. Here 4 times. 4 2s are 8 pi minus, here 2 times will 1. 2. Now 3 pi plus 8 pi is 11 pi. 11 pi minus 2 pi is clearly 9 pi by 12. You can cancel with 3. 3 3s are 3 4s are. What is the final value? 3 pi by 4. That is the final answer for that. Next, coming to 12th question. 12th one. We need to find the value of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. I think you can do directly here, no problem. Easily you can find out. Cos inverse of 1 by 2 means cos is 1 by 2 at which angle? Pi by 3. Directly I can get angle is a pi by 3 plus 2 into sin inverse of 1 by 2 means sin inverse is 1 by 2 at which angle? Pi by 6. That's why directly I am getting that angle pi by 6. You can count 2 ones are 2 threes are. Now what is pi by 3 plus pi by 3? What is the final value? 2 pi by 3 is the final answer. Let's come to the next question, 13. If sin inverse x equal to y, then we need to find the y range, what the y is belongs to. Now clearly x is the domain, y value is the range of the function. That's why y range, sin inverse x range, what here? It is a closed interval minus pi by 2 to plus pi by 2. Clearly the y value, y is belongs to closed interval minus pi by 2 comma pi by 2. So also we can write in inequality form, that is what y lying between minus pi by 2 to plus pi by 2 and include both. That's why this we can write minus pi by 2 less than or equal to y less than or equal to pi by 2. That is actually multiple choice question. You can check, it is option B is the correct one. Sin inverse x is equal to y, then we need to find y value range. What is the limitations? It is clearly lying between minus pi by 2 to plus pi by 2. Next, 14th one. Find the value of tan inverse of root 3 minus secant inverse of minus 2. This value we need to find out. Directly we don't know the values of this. Now for example, let tan inverse of root 3 directly we can write, no problem. Because tan inverse is root 3 at which angle? Pi by 3. So directly we can write, because it is as per table only we can identify. But secant inverse of minus 2 we don't know directly. That's why I take the value, that is some y equal to secant inverse of minus 2. First of all directly we got, take secant inverse left side will becomes secant y equal to minus 2. Directly we not able to convert this into secant angle. That's why secant y equal to minus, where at which angle secant is 2? It is clearly at pi by 3 at 60 degrees. That's why in the place of 2 I am writing secant pi by 3. Now, but we are not able to compare these angles because there is a opposite sign. We can write this minus secant theta in terms of secant of pi minus theta, because secant is negative immediately in which quadrant? Second quadrant. That's why secant y equal to, in the place of minus secant pi by 3 we can write secant of pi minus pi by 3. Now your secant y equal to secant, by taking LCM what you get? 2 pi by 3. Now y equal to 2 pi by 3. Now from this we can find the value of given term tan inverse of root 3 minus secant inverse of minus 2. Tan inverse of root 3 is clearly pi by 3 minus secant inverse of minus 2, because here y is what again? Secant inverse of minus 2 equal to 2 pi by 3. So secant inverse of minus 2 is 2 pi by 3. The LCM is 3 only. Pi minus 2 pi is clearly what? Minus pi. Now minus pi by 3 is the value of tan inverse of root 3 minus secant inverse of minus 2. Next we will discuss properties of inverse trigonometric functions. Now we have to use properties to evaluate a certain format of functions. Directly finding by using basic angles we are not able to find. That's why we are using these properties. In this first one, how to evaluate sine of sine inverse x. Now using trigonometric, it is an inverse trigonometric. Resultant value you get here x. But what is the x value we need to take here? You should remember this one. Sometimes we'll ask for 1 mark questions. So x is clearly, as for this inner function, what here? Sine inverse x. X is clearly number. Number means what is the domain of sine inverse x? Clearly x is belongs to domain is what? Closed interval minus 1 comma 1. Now same thing, if you change this one, what? Sine inverse of sine x. Here also what you get resultant value is x. But here x what you have to take here? X is clearly angle. Angle means as for restricted one, as for restricted domain, what is the value you have to take? Closed interval minus pi by 2 comma pi by 2. Not taking all real numbers. Similarly, you can take for cos. Cos of cos inverse x equal to x. Here x is clear again what? When cos inverse is there, x clearly number. When you take number, as for this domain of this what here? Closed interval minus 1 comma 1. Next, cos inverse of cos x is equal to x. Here x we have taken angle. As per restricted value, what have to take? Closed interval 0 comma pi. Next, tan of tan inverse x equal to x. But x what we take? You can take all real numbers. For set of all real numbers, it is satisfied only. So here x is belongs to R. Set of real numbers. Next, coming to tan inverse of tan x. This also gives x only. For what values of x? Here x is clearly angle. As restricted values, what have to take? Open interval minus pi by 2 comma pi by 2. This is our set of 3. Remaining 3 also you can write, but these 3 set of values is enough. Sine of sine inverse of sine. Similarly for cos and tan also. Coming to next, second set of properties. In this, sine inverse of 1 by x equal to cosecant inverse x. But how to remember what is the x value we need to consider? Simple logic is here. For all set of what is here right side function is a cosecant inverse x. What is the domain of cosecant inverse x is? Domain of cosecant inverse x is all real numbers minus open interval minus 1 comma 1. This set of values we need to consider for this. Now to just check this one, how to prove this one condition. Take the LHS value, consider as y equal to sine inverse of 1 by x. We can prove this one LHS to RHS value. Now take this sine inverse left side, it will become sine y equal to 1 by x. Now x take left side, sine y take right side, it will become x equal to 1 by sine y. Now x equal to, what is the 1 by sine y? 1 by sine is called cosecant y. Now take this cosecant left side, it will become cosecant inverse x equal to y. Now finally, now what does the y means? Sine inverse of 1 by x. So finally what you can write? Sine inverse of 1 by x is equal to cosecant inverse of x. And this is from just simple proof proving from LHS to RHS. How to check this x values are satisfied? Take any number and substitute in this both side. Both you will get equal values. This is one set of property. Sine inverse of 1 by x equal to cosecant inverse x. Second, first one. Coming to second one similarly. Cos inverse of 1 by x equal to secant inverse x. Here also what is the x holds or x belongs to? Here right side what is the function is there here? Secant inverse x. So the domain will be considered here. X belongs to r minus open interval minus 1 comma 1. Coming to third one, tan inverse of 1 by x equal to cot inverse x. But here don't take the domain of cot inverse x directly. The reason, what you are taking x value clearly. For example, if you take x is 0, when you take x is 0, what you have tan inverse of 1 by 0 and cot inverse of 0. Now tan inverse of 1 by 0 means what you have to get infinity. But as for range of tan inverse, what is the range of tan inverse? Open interval minus pi by 2 comma pi by 2. In this, pi by 2 is not included. That's why should not take 0, should not take negative also. For example, if you take in minus 1 will take. For 0 it is not satisfying. Reason, tan inverse of infinity, the angle does not exist. It is not in the range of the function. If you take minus, negative value you take. Negative value you take means tan inverse of 1 by minus 1, what you get? Minus 1. Cot inverse of minus 1. Tan inverse of minus 1 clearly minus pi by 4. At minus 45 it is possible. But this is not equal to minus pi by 4. It is equal to 3 pi by 4. Both are not equal. For negative not satisfying and for 0 also not satisfying. That's why we are taking only positive values. Positive values means, what is the value? All greater than 0. This is the x value belongs to all positive values only, it is satisfied. Here as for domain we can write. For third one, we need to consider only positive values. It's coming to the third set of properties. Now in this first one, sin inverse of minus x equal to minus sin inverse x. Here, what is the x holds or x belongs to means simple. Just you have to write the domain of sin inverse. What is the domain of sin inverse? It is clearly x value belongs to closed interval minus 1 comma 1. Now to prove this one, it's simple. I will explain one question in this. Now let take the value y equal to sin inverse of minus x. I'm taking LHS value. From this we need to prove RHS. Take sin inverse left side, it will become sin y equal to minus x. Take minus this side, minus sin y equal to x as a condition of this. Well, now minus sin theta also we can write sin of minus theta equal to x. Minus sin theta we can write sin of minus x, like that, sin of minus y. Now take this sin right side, it will become sin inverse of what here x. Now take this minus right side, it will become minus sin inverse x. What is the y actually? Y is sin inverse of minus x equal to minus sin inverse x. And we can check any value in between this interval, it is satisfied for both LHS and RHS. Similarly, next second one, tan inverse of minus x equal to minus tan inverse x. When you have to use this value, just simple, if inside negative number is there, you can take minus 3 multiple. Takes out common. Here what I have to take x value, clearly the domain of tan inverse only, all real numbers. Next, third one, cosecant inverse of minus x. So also minus will 3 multiply minus cosecant inverse of x. Here what I have to take here again, domain of cosecant inverse only, that is r minus open interval minus 1 comma 1. Next, coming to fourth one, we learn for 3 set of inverse trigonometric functions: sin inverse minus x, tan inverse minus x, and cosecant inverse of minus x. For these 3, minus will be pre-multiplied for next 3. For example, first one, cos inverse of minus x. This is not equal to minus cos inverse x. This is clearly pi minus cos inverse x. Now what is the x value clearly? As per domain of that function only. Closed interval minus 1 comma 1. Sometimes they will ask, they will give this equation and what is x value they will ask. What is x holds for what set of values this equation satisfies. I will explain this one, how to prove this condition. Let y equal to cos inverse of minus x. Now take cos inverse this side, it will become cos y equal to minus x. Take this minus left side, minus cos y equal to x. But here not able to take minus inside, cos of minus y is not equal to minus cos y. Minus cos theta we can write cos of pi minus theta. We have formula. As for that, minus cos y we can write cos of pi minus y equal to x. Now take cos right side, pi minus y equal to cos inverse x. Now interchange both, y take right side, cos inverse take left side, becomes pi minus cos inverse x equal to y. What is the y stands for here? Cos inverse of minus x. Finally, cos inverse of minus x equal to, what is the value? Pi minus cos inverse x. This is proof for this question. Cos inverse of minus x equal to pi minus cos inverse x. Next, in the second one, this is a 2019 and 20 2 marks question. In the March exam they asked cot inverse of minus x equal to pi minus cot inverse x. Here again, what is the x holds here? Clearly, x is belongs to the domain of cot inverse only. That is, x belongs to R. Now to prove this one. Take same we did in previous one like that only. Let y equal to cot inverse of minus x. Now take cot inverse left side, it will become cot y, that is equal to minus x. Take minus left side, so minus cot y equal to x. Same here also, not able to take cot inside, so we are writing minus cot theta in terms of cot of pi minus theta, because cot is negative immediately in second quadrant. So minus cot y we can write cot of pi minus y equal to x. Take cot right side, now pi minus y equal to cot inverse x. Now interchange y value on cot inverse x. Now pi minus cot inverse x equal to y. And what is the y? Cot inverse of minus x. Finally we can write y value is cot inverse of minus x. And what is the equal to value? Pi minus cot inverse x. This is simple proof, very easy. Cot inverse of minus x equal to pi minus cot inverse x. Similarly, you can try this one. Third one is also very easy. Secant inverse of minus x equal to pi minus secant inverse x. And what is their x holds? The domain of secant inverse x only. Domain what? R minus open interval minus 1 comma 1. Next, coming to next one, fifth one. This also all are very, very important for 2 marks questions, last group. And the formula is also very, very important. In the first one, sin inverse x plus cos inverse x equal to pi by 2, where x is belongs to closed interval minus 1 comma 1. Again, how to identify? For sin inverse x domain is same, for cos inverse x also domain is same. For the sum also common domain, that is minus closed interval minus 1 to plus 1. Now to prove this one. Say first take any one function. Let I am taking y equal to sin inverse x. From this we will get total equation. Take sin inverse left side, it will become sin y equal to x. Already we know sin pi by 2 minus theta, or if we take cos pi by 2 minus theta, what you will get? Sin theta. Sin theta we can convert in terms of cos, because the term rectified in terms of pi by 2 angle. That's why this sin y I will change in terms of cos. How to change this one? Sin y I can write cos of pi by 2 minus y equal to x. Now take cos right side. Pi by 2 minus y equal to cos inverse x. Now pi by 2 minus y take right side, that is plus y plus cos inverse x. What is the y value? Sin inverse x. Pi by 2 equal to sin inverse x plus cos inverse x. Finally we can write sin inverse x plus cos inverse x equal to pi by 2. It's a very simple, very easy, but 2 marks question. Next, second one. Solves important for 2 marks. Tan inverse x plus cot inverse x equal to pi by 2. Here also what is the common domain for tan inverse and cot inverse is clearly all real numbers. That's why here x belongs to R. Same how to do this one. Let take tan inverse x is considered as pi. Now take tan inverse right side, it will becomes x equal to tan y. Now we can convert tan in terms of cot. How to change? Cot of pi by 2 minus theta equal to tan theta. Cot of pi by 2 minus theta equal to tan theta. That's why x equal to, in the place of tan y, I can write cot of pi by 2 minus y. Converting from tan to cot. Now take cot the left side, it will become cot inverse x equal to pi by 2 minus y. Now take this minus y left side, it will become plus y. Y plus cot inverse x equal to pi by 2. And what is the y value? Y is clearly tan inverse x plus cot inverse x equal to pi by 2. So coming to the third one. Secant inverse x plus cosecant inverse x equal to pi by 2. Formula wise also is very, very important, each and every property. And what is the common domain for common x values for both? Clearly R minus open interval minus 1 comma 1. How to prove this one? Say let take any one function. Secant inverse x equal to y. Consider sin secant inverse x equal to y. Now take secant inverse is right side, becomes x equal to secant y. Again same, the secant y changing into cosecant. How to change? Cosecant of pi by 2 minus theta equal to secant theta. In the place of secant theta, we are changing in terms of cosecant. So x equal to cosecant of pi by 2 minus y. Now take cosecant left side, it will become cosecant inverse x equal to right side pi by 2 minus y. Now take this minus y left side, it will become plus y. Now y plus cosecant inverse x equal to pi by 2. Now what is the y value? Secant inverse x plus cosecant inverse x equal to pi by 2. Each property is important, including proof also. Practice everyone. Coming to sixth property. In this there is 3 set of properties are there. Each one is important for 3 marks. That first one, prove that tan inverse x plus tan inverse y equal to tan inverse of x plus y by 1 minus xy, comma, if x greater than 0, y greater than 0, xy is less than 1. These are the restrictions for x and y values. For this we need to prove this one from LHS to RHS. Now let's consider this is A and this is B. Let A equal to tan inverse x, B equal to tan inverse y. Now take tan inverse left side, becomes tan A equal to x, and tan B equal to y. When you consider this A and B, this will become A plus B. Now when you consider tan inverse left side, it will become what here? This is A plus B. Tan inverse left side, it will become tan of A plus B. Now which formula use here? Clearly we know that tan of A plus B formula. Tan of A plus B, what is the formula? Tan A plus tan B by 1 minus tan A into tan B. What is the tan A value? X plus tan B value y by 1 minus x into y. And before converting or changing tan right side, we need to check if the conditions. What the conditions given? Given that x is greater than 0, y is greater than 0, and xy is less than 1. X positive, y positive, xy is less than 1 means below 1. When it is below 1, 1 minus xy also becomes positive. Numerator also positive because both are positive, sum also positive. 1 minus xy, because xy is less than 1 means, for example, 0.5. 1 minus 0.5 is 0.5 is clearly positive. So overall value also becomes positive. What? X plus y by 1 minus xy is clearly greater than 0. When this value is positive, tan of A plus B also positive. What? Tan of A plus B is greater than 0. As for the tan is positive, which quadrant? First quadrant. As for complete range, minus open interval minus pi by 2 plus pi by 2. At negative angle is not positive. For positive angle means from where to where? 0 to pi by 2. That's why this A plus B angle clearly lying between 0 to pi by 2. Now clearly we can convert now tan in terms of tan inverse function. Now from that, from equation 1, take tan right side. Now it will becomes A plus B equal to tan inverse of x plus y by 1 minus xy. Now what is the A value? A is tan inverse x. What is the B value? Tan inverse y equal to tan inverse of x plus y by 1 minus x. It is important for 3 marks. 3 marks very, very important. Coming to the second one. Prove that tan inverse x minus tan inverse y equal to tan inverse of x minus y by 1 plus xy. Here x is greater than 0, y is greater than 0, and xy is greater than minus 1. These are the conditions given, values wise. It's more than minus 1 values. Coming to proof, let assume each value tan inverse x equal to A, and tan inverse y equal to b. Now x equal to tan a, y equal to tan b. Now after assuming it is a and b, it becomes a minus b. We need to apply a formula tan of a minus b formula. So we know that tan of a minus b equal to what formula? Tan a minus tan b by 1 plus tan a into tan b. Replace what's the tan a value? It is x. Tan b is y by 1 plus x into y. Left side what is the value? Tan of a minus b. It's considered as equation 1. Before converting the trigonometry to inverse trigonometry, take right side. We need to check this is a positive or negative. Then only we convert the values. Now, what they given? It's given that x greater than 0, y greater than 0, and the xy is greater than minus 1. So more than minus 1 if you take any value. More than minus 1 means, for example, 0 take. If you take here 0, so 0 is not a positive. For example, if you take 1, for example, more than 1 also, more than 1. 1 plus 1, it is a positive. Now x and y both are positive one. Now positive one, one more thing we need to follow a condition. Another condition is x is greater than y. X is greater than y. One more condition we need to remember here. Another condition we need to add here. X also greater than y and xy is greater than minus 1. Now we can say clearly x is always more than y means x minus p is clearly positive will come. And as for this 1 plus xy also positive. Now from this total value is positive. Now total value what? X minus y by 1 plus xy clearly greater than 0. And another condition that is x is greater than y. Now this value is positive means tan of a minus b also positive. Tan of a minus b is greater than 0. Tan is positive in which quadrant? Clearly first quadrant as per that. Now it is clearly angle a minus b lying between 0 to pi by 2. Now as per this angle, we can convert now tan right side. From first equation, take tan right side. So a minus b equal to tan inverse of x minus y by 1 plus xy. Now replace a value and b value. What is a value? Tan inverse x. B value tan inverse y equal to tan inverse of x minus y by 1 plus xy. So second one proof. Next. Sixth, third one. Prove that tan inverse x plus tan inverse y equal to pi plus tan inverse of x plus y by 1 minus xy. Here condition changes. If x greater than 0, y greater than 0, xy also greater than 1. So first one, xy is less than 1. For that, the pi is not come, but here, because of xy is greater than 1, the nature changes here, pi plus will get. Coming to proof, same, let's assume a equal to tan inverse x and b equal to tan inverse y. Tan inverse take left side becomes tan a equal to x, tan b equal to y. As for the general only, this becomes a plus b. We need to use tan of a plus b formula. We know that tan of a plus b equal to tan a plus tan b by 1 minus tan a into tan b. Now tan a value is x, tan b value 1 minus x 2. Consider as equation number 1. Now what are given conditions? Given that x is greater than 0, okay, y is greater than 0. Next one more is given what? xy is greater than 1. Numerator is clearly positive because both are positive values, sum also positive. xy is greater than 1 means, for example, if you take 2 xy value, 1 minus 2, it will becomes negative. Positive by negative, it is clearly negative. Here, the value becomes what here? X plus y by 1 minus xy, clearly negative. When this is negative, tan of a plus b also negative. Tan of a plus b is negative, okay. Tan positive in first quadrant, we know that. Tan immediately negative, which quadrant? Second quadrant. Second quadrant, what is the limitations for angle? 90 to 180. 90 to 180 means pi by 2 to pi. That's why this a plus b angle clearly lying between pi by 2 less than a plus b less than pi. But to convert from tan to tan inverse, what is the range of tan inverse? You should remember. What is the range of tan inverse? Open interval minus pi by 2 to pi by 2 only. Pi by 2 to 180 is not there. That angle should not appear there. That's why we need to reduce the angle in between this interval only. Either 0 to pi by 2 or minus pi by 2 to 0. That's why to reduce this angle, I will subtract each and every value with pi. Now by subtracting each and every value with pi, pi by 2 minus pi less than a plus b minus pi less than pi minus pi. Now 90 minus 180 is minus 90. Minus 90 means minus pi by 2 less than a plus b minus pi less than 0. Now clearly, now observe, minus pi by 2 to 0, it is existing in the range or not? It is clearly there. Now in the place of a plus b, we need to replace the angle. What here? A plus b minus pi. Now from first equation, the a plus b angle we need to replace with a plus b minus pi equal to what? X plus y by 1 minus xy. Now take easily. Now because this angle clearly as for the range only, now we can convert easily from tan to tan inverse. A plus b minus pi equal to tan inverse of x plus y by 1 minus xy. Now take minus pi right side, it will becomes plus pi. Pi plus tan inverse of x plus y by 1 minus xy. Now what is a value? Tan inverse x. B value is tan inverse y. Now tan inverse x plus tan inverse y equal to pi plus tan inverse of x plus y by 1 minus x. Now this is a proof for third one. To 7.1. This proof is also important for 2 marks. This first one, prove that 2 tan inverse x equal to sin inverse of 2x by 1 plus x square. Here also sometimes there will be this property equation and they will ask x value for 1 mark question sometimes. Here what is x value? It takes a simple, easily can remember, the domain of sin inverse taken off. X belongs to closed interval minus 1 comma 1. This one you can write in several manner, but this is easy way you can remember domain of sin inverse. How to prove this one? I will pull this one from RHS. From RHS it is easy. What is RHS? Sin inverse of 2x by 1 plus x. We need LHS in terms of tan inverse. That's why we will take, let x equal to tan theta. Take in terms of, take tan inside will become tan inverse x. Now sin inverse of 2 tan theta by 1 plus tan square theta. Sin inverse of 2 tan theta by 1 plus tan square theta is a formula of which one? Sine 2 theta. That's why here I can replace sine inverse of sine 2 theta. Already we know first property, sine inverse of sine x is x. That's why as for that, both will be cancelled. We get 2 theta. 2 from this. We can find theta. How to find theta? Take tan left side. Now it will become tan inverse x equal to theta. Now 2 theta means tan inverse x. It is equal to required LHS. Coming to next second one. Each one is important. Prove that 2 tan inverse x equal to cos inverse of 1 minus x square by 1 plus x square. Here, the x value clearly greater than or equal to 0. Not for. How to verify? Simple thing. Take any value for this and substitute in both sides. It will be satisfied. Now this all three we are moving from RHS to LHS. Now easy method. Take the RHS. RHS, what is there? Cos inverse of 1 minus x square by 1 plus x square. Say we need LHS in terms of tan inverse. That's why take let x equal to tan theta. Take tan theta only from this. Tan inverse x equal to theta. Now what will you get? Cos inverse of 1 minus tan square theta by 1 plus tan square theta. 1 minus tan square by 1 plus tan square formula, which one? Cos 2 theta formula. That's why cos inverse of cos 2 theta. Now cos inverse, cos will be cancelled. We will get 2 theta. What is theta value? Tan inverse x. 2 tan inverse x, that is required LHS.
Okay.
Third one, prove that 2 tan inverse x equal to tan inverse of 2x by 1 minus x square. Here x value clearly lying between minus 1 to plus 1. This also we can write like this. X belongs to open interval minus 1 comma 1. Say, take RHS. What is RHS? Tan inverse of 2x by 1 minus x square. We need LHS in terms of tan inverse, that's why x take in terms of tan. Here, let x equal to tan theta. From this, tan inverse x equal to theta. Now tan inverse of 2 tan theta by 1 minus tan square theta. We don't know this formula. What is left is there? Tan inverse. Tan inverse will take tan function. Sin inverse is there? Sin. Cos inverse means cos. Here tan inverse of 2 tan theta by 1 minus tan square theta formula is tan 2 theta. For tan inverse is there before bracket, so take tan. For example, sin inverse is there, take sin 2 theta. Both will be cancelled. What will get here? 2 theta. Now 2, what is the theta value? Tan inverse x. That is required LHS. So important for 2 marks, very very important. Next, coming to 8th one. This 8, both questions are very very important for 2 marks. Important models. They ask continuously in 2 years. In that first one, prove that 2 sin inverse x equal to sin inverse of sin, or you can take like this one question. Prove that sin inverse of 2x into root of 1 minus x square equal to 2 sin inverse x. So the limitation I take here, the value lying between minus 1 by root 2 less than or equal to 1 by root 2. It's lying between from minus 1 by root 2 to plus 1 by root 2. This is the question. You have to prove that sin inverse this one, we can prove from LHS only. What is the LHS? Sine inverse of 2x into root of 1 minus x square. X, what you have to take here? RHS in terms of sine inverse required. That's why take x is sine theta. Put x equal to sine theta. From this sine take left side, what will you get? Sine inverse x equal to theta. Now substituting the LHS value. Sine inverse of 2 sine theta into root of 1 minus sine square theta. Sine inverse of 2 sine theta. 1 minus sine square theta is what? Cos square theta. Now it is cos square theta. Now square root is cancelled. Sine inverse of 2 sine theta into cos theta. Now 2 sine theta cos theta is which formula? Sine 2 theta. Don't know just symbol. Sine inverse is there. Write in terms of sine. Sine inverse of sine 2 theta. Now sine and sine inverse both will be cancelled. Now what will you get here? 2 theta. 2 theta is what here? Sine inverse x. That is the required RHS. Next, take the second one. This is also very important for 2 marks. Prove that same sine inverse of 2x into root of 1 minus x square we need in terms of cos inverse. 2 cos inverse x. Here limitation is 1 by root 2 less than or equal to x less than or equal to 1. To take same thing, how to do this one? Take the LHS. Sine inverse of 2x into root of 1 minus x square. Now I have doubt which one I will consider here in terms of sine inverse. Let's say take sine theta. Now we need in terms of here what? Cos inverse. That's why I put x value in terms of cos theta. Theta what will get here? Cos inverse x equal to theta. Substitute x value what? Cos theta in LHS. Sine inverse of 2 cos theta into root of 1 minus cos square theta. Sine inverse of 2 cos theta into root of 1 minus cos square theta is sine square theta. Now square root both cancelled. Sine inverse of 2 cos theta into sin theta or 2 sin theta into cos theta. Both are same. So that is a formula for which one? Sin 2 theta. Sin inverse both are cancelled. You get 2 theta. What's the theta value? Is cos inverse x. That is required RHS. Today we discuss very important properties. For some properties we given formulas directly, and for some properties we given proof also. The top for which property is given proof is very important. You need to practice compulsory in homework notes, and we need to prepare classwork today only. Whatever in the class we discussed, we need to prepare the notes, and the same day we need to practice each and every question and properties compulsory.